Expanded Bed Adsorption, or EBA, is an advanced integrated unit operation for the downstream processing of biomolecules directly from a bioreactor, where clarification, concentration, and purification are performed in a single step. So 3 discrete unit operations, namely solid-liquid separation, volume reduction, and partial fractionation, can be replaced by a single EBA capture step to reduce processing costs and time and product losses. EBA chromatography's higher process and energy efficiency as compared to conventional techniques have led to several applications ranging from the purification of therapeutic and commercial proteins to enzymes from yeast, mammalian, algal, expression systems, and plant extracts. In EBA, an appropriate stationary phase is fluidized by applying the mobile phase in an upward direction, generating a bed of enlarged interparticle spaces. The expanded void portion of a fluidized bed permits the application of a feedstock without clogging the bed. Hence, the purification of biomolecules by adsorption is an effective initial purification step for biomass-containing suspensions. A stable fluidized bed is formed when the adsorbent particles are suspended in equilibrium due to the balance between particle sedimentation velocity and upward liquid flow velocity. Crude and clarified feedstock is applied to the expanded bed with the same upward flow as used during equilibration. The target molecule in the feedstock interacts with the beads through a specific ligand and becomes adsorbed, while cells, cell debris, particulates, and contaminants travel around the adsorbent beads and ultimately escape unhindered through the top of the column. The weakly bound materials, such as residual cells, cell debris, and other particulate materials, are washed out from the expanded bed using a wash buffer. After all weakly retained materials have been washed out from the bed, the bound target protein is eluted. The captured proteins are eluted from the sedimented bed using suitable buffer conditions. The elute contains the target protein, increased in concentration, clarified, partly purified, and ready for further purification using packed bed chromatography. After elution, beads are regenerated by washing them with strong buffers specific to the type of chromatographic principle being used. Regeneration removes the more strongly bound proteins which were not removed during the elution phase to restore the original performance of the beads. Therefore, expanded bed adsorption is an ingenious approach to reducing the steps required in primary purification while simultaneously allowing for the processing of fermentation broth with extremely high titers. At first glance, expanded bed adsorption is similar to classical chromatography, but the drawbacks and requirements of traditional chromatography are mostly circumvented in EBA due to lower pressures and higher flow rates made possible by a fluidized bed.